Hello and welcome to this Oasys webinar on GSA modelling tips and tricks. Now, important thing to remember with any finite element analysis modelling is keep it simple. Keeping it simple is possibly one of the hardest parts of engineering analysis. It's very easy to make something very complicated so you get lost. But unfortunately that you'll have to how to keep things simple. Something you have to learn yourself. So, general modelling, first of all. Main thing to look at here is axes. I think everybody's familiar with the Cartesian coordinate sets. We do also have cylindrical and spherical axes in GSA as well. These can be very useful. But with that, let's have a look at GSA itself and some of the things you can do in GSA. Okay, first of all, just to start a new model. Title screens, these should be job numbers which you can recall, initials. So all these things which will appear on your printouts and so on. In the new model as well, we do have a number of model types. Space frame probably isn't the most common, but we do also have the different types like a plane frame, grids for a floor, plane stress and plane strain models, and axisymmetric models. But what I'm going to do, I'm going to leave all that blank for the moment, and I'm just going to create a new model. And I'm also going to use a keyboard shortcut, which is Control and 5, which just maximizes the view. Now, this Control 5 has to be the number keypad, and you know 5 is the one in the middle, 6 is on the right hand side, 4 left hand side, 7 top left hand corner, and so on. These can be quite useful, especially the 5, because it maximizes the view without maximizing the view, which means it helps prevent you getting lost in too many windows if you're not careful. Now, we do, as part of the sculpting tools, we have this sculpting toolbar which you can switch on and off using this button here. It defaults being off, so not everybody spots it, is a draw grid. Now this draw grid by default is 1 meter centers, but we can define this current grid, and then you notice also there's a keyboard shortcut, and we can then change this snap grid. So by default it's 1 by 1, but we can make it 1 by half and automatic sense. And so you can use this for snapping too. For example, if I use the add elements tool, you notice it's, see with the red cross, it's trying to snap to these points. There is an option there to not snap the points, and if you look at the coordinate in the bottom left hand corner, you'll see it is still snapping, but it's a rounded value. And if I zoom in, the snap value gets a bit more detailed. Now this grid system doesn't have to be square. As I mentioned, we do have things like cylindrical and spherical, and if I change this to the global cylindrical grid, suddenly we've got a grid suitable for dealing with circular structures and so on. So for example, if I was to take this, so if I just scale that view, we've got this element there with an automated grid. If I was to copy that element, let me switch the nodes on so we can see where we are. We can use this move and copy commands, and at the moment the default axis is cylindrical, though we can pick and choose which axis we go for. And if I use this copy on the cylindrical basis and radius stays the same, it says the same. If I just change the angle to 60 degrees and add in 5 copies, lo and behold, we instantly have a circular structure. Let's just switch that grid off the moment so maybe see a bit better. Now, with these copy move commands, we can also do some interesting things with nodes, for example. I mean, if I was to select those nodes, and you can use the move copy, but I can move these nodes, and we can X, Y, and Z coordinates, or in this case, radius, angle, and Z, and I can increase the radius by ½ meter. Or alternatively, if I select multiple nodes, I can then go, and then rather than copy, you notice there's a drop down button here, I can say Shift 2 and just make that 1.5, and this will move all of these to the same value. So by default it's moving by a value, but you can move to a value as well, so this can be very useful for just neatening things up. Right, let's go back to the general. Now, 1D elements, mainstay of majority of GSA models. That's basically doing beam and slabs. So, beam elements. Now, beam elements, apart from the global axis, they also have their own individual axes. X being along the beam, Z being the perpendicular to the X, which is as vertical as possible, and then Y being the remaining perpendicular direction to that. Now, because the Z wants to be as vertical as possible, once you do have a column, so a beam which is vertical, there is no vertical perpendicular direction, and so you have to have a new rule which has the local Y is parallel to the global Y. There is a straightness tolerance or verticality tolerance which is set in your preferences, so I think it's within a couple of degrees by default, and this rule then takes over. You will find though, if you import a column, for example, from CAD, and maybe there's a few rounding errors or something like that, or badly drawn in the first place, you might find the solid section rotating round as you view it, and that's because the column is not quite vertical. Something to watch out for. We have orientations or rotations on the elements. For example, we have both an orientation angle and an orientation node. Now, this is by default, this one here. You can add in an orientation angle onto them to turn them all around, or you can orientate them all to a node. For example, they're all orientating themselves to that node in the corner, or of course make a combination of the two. Very useful obviously for circular buildings, also very good for roofs, sloping structures and so on, where you're not necessarily quite sure of what the angle should be, but if you've got a node you can orientate elements to, you can make use of that. So let's have a go at that in GSA. I'm going to just delete all that. In fact, let's just close that model and start a brand new one. Okay, let's turn on the snap grid, and I am going to draw you a staircase. Now, there's a snap grid. We can add in elements and nodes just by typing things straight into the table views. For example, we do have the shortcuts across the bottom, but you can access these through the gateway down here, and I'm going to add in by default enter a node at 0, and then a node 1 meter across, and 1 meter up, and that should now give us 4 nodes. Let's just switch that grid off so we can see better. So there I have our 4 nodes, and I'll switch the node numbers on, and then I'll go to the elements table, which again can be through here or through the gateway, and I am going to add in a beam, property 1, group 1. We can set properties later. No orientation node, no orientation angle, and going from node 1 to node 2. Not the dummy. You can see there we have our beam running across the bottom. And likewise, we can go from 4 to 3, or just do a down arrow to copy all the other defaults across. Now, this is quite can be a useful way of working, can be rather slow. Once we've got the nodes or a snap grid in there, we can just use the sculpt tool, and it snaps to the existing nodes and draws it in. Okay, now so there is our, this is going to be our ground floor landing. What I'm going to do now is I am going to use a rather cunning tool called extrude. Now extrude is a bit like the copy, but it can copy things and create other elements in the process. So if I select those nodes there, and under the sculpt command menu, there is extrude selection. Now you know with extrude it only works in a single simple vector, unfortunately. So I'm going to extrude these nodes along the level. These are going to be my staircase stringers. And if I create 2 increments of 1 meter each, if I just do that, it copies the nodes. If I click on this include beam elements, it will actually include the stringers as well. Now that's extruding the nodes, and I just cancel that, and rather than the nodes, I am going to select that member, or element I should say, and use my repeat command. X direction, again 2 increments, 1 meter, include beam elements, and rather than just creating the stringers, it creates the cross members as well. Say OK to that. Now this is going to be a staircase. This is on level, so that's not ideal. So what we need to do is adjust this so it's sloping upwards. Now, because the elements are defined by the nodes they're connected to, if you move a node, such as that one there, and move copy, move that in the Z direction by 0.5 meter, and that one there, move that one up by 1 meter, then yeah, so you move the nodes and the elements will follow, and that can be very useful for small numbers, but as you can see, if you having multiple step elements, you've got to move each node individually with its own coordinate system, but coordinate change. But if I select these 3 nodes here, there's another cunning tool which not enough people know about called flex. Now I want to move these 2 nodes, but not that one, but I have selected it anyway because this is going to be an anchor point. If I right click on this node over here, which is going to be my move one, I right click directly on the node and choose the flex line of nodes command, I'm going to move that node up 1 meter, and that's going to be a linear flex, which means all the nodes are going to remain in a straight line, which can be spaced evenly or proportionally. And you notice we do also have other commands about circular, elliptical and parabolic, so you can create curved surfaces quite quickly. If I preview that, you see this node's moved up 1 meter, this node's moved half of that because it's halfway, and this node at the far end has moved nothing at all. Recommend you have a good play with that one. It's quite a useful command. Now, I'm just going to create the top landing again by using the extrude command. Extrude and just copy over 1 meter. And extrude in the other direction. Okay, now this landing is a little bit large. I want this part of the structure a little bit smaller. I mentioned about moving the nodes. Now, if you move the nodes, then these elements will adjust. If you make a mistake and move those elements, you'll find they will detach from here. So if I was to move those elements, I'll move them sideways, just so it's a bit clearer. Let's say move that minus 1.5. Oh, come on, all confusing. Yeah. So if you move it 1.5, you see it moves the elements, detaches from the elements which are not moving, and creates new nodes. So what we actually want to do is move those nodes instead, and if we move the nodes, you see everything else follows. Okay, so we have a half landing. Now, using extrude or copy and so on is one way of creating these sloping members. There is another way, if you know what the angle is, by using user-defined axes systems. And let me first of all switch on the user axes so we can see them once we create them. Now, I am going to define an axis. Now, you can define axes directly just by typing in the type, origin points and vectors, but to be honest, it's much easier to use the sculpt tools, copy a node and then use that as a point. So I'm going to select that node there. I am going to copy that node, and remember we have this 1 and 2 slope for the bottom, and I'm going to copy that x of -2 and y of 0 and z of 1. Look at the elevation. See, we've got a 1 and 2 slope, and so what I'll then do is I'll select those 3 nodes, and these 3 nodes will be used to form the basis of the coordinate system. So let's use the sculpt, use axes, and then we can then toggle our way through the various axis sets until we get to one which we like, and I'm going to call that upper landing, upper stair. Sorry. You can see the colours red, green, blue, and these match the red, green, blue global axes. So red is X, green is Y, blue is Z. We see we now have an upper stair axis, and we've also got, let's refresh that, we also got a number of nodes. Some are red, some are black, and what I'm going to do is I'm going to select all my nodes. I want to get rid of that red node there, but having selected all the nodes, I can hit the delete button, and it will only delete the nodes which are not in use. You cannot delete a node in the graphical view which is in use. You can delete nodes from the table view which are not in use, so delete from the table views with care, but from the graphical views it's quite safe. Now, with this axis set defined, I am going to extrude this element up, and rather than the global axis, I'm going to choose this axis that I've just created, and it's going to be the Y direction, and I'm just going to do it one increment, 2 meters along, and include beam. And then we have our upper staircase. Now, I've forgotten to put the cross member in. That's okay. Because what I'll do is I want to pick one of these elements. I can use the split command to break it down to number of pieces. Now you notice there's choices in here about equal parts, split at a distance from an end, split at a percentage, split at existing nodes as well. I'm trying to break this one into 2 pieces. And then I can use the sculpt tool to add in the other. Notice I didn't split both of them, because with the add elements tool, you notice obviously you can snap onto the nodes, but you can snap onto the elements as well. And if I right click, you see there are options about snap to center, snap to perpendicular, and snap align with grid axis. Now in this case, all 3 of those options will give the same result, but obviously if they weren't perpendicular, then they wouldn't. So if I snap to that element there, you see it then breaks that element up into 2 pieces. Now this snap tool, not snap tool, split tool, if I just select those elements there, I'm just going to break those up into 2 pieces for the moment. Now if you've over broken elements, if that's the right word, there are tools for joining things up again. I'll select all those 4. This was added in I think in the current release. The option under the sculpt tools, joining strings of 1D elements. If I choose that, you'll note that the elements which are in a straight line and the same properties and so on have joined up. If I just delete those nodes out, you note that the those elements GSA could join together have been joined. The elements which were not in the straight line have not been joined. So this is quite safe to use in over quite a large scale. Okay, we've got general structure. We need support points now. Overall restraints. Now, supports or restraints are at nodal locations. If I pick those 2 nodes there, I can modify those, pin them, have them fully fixed. Note that we do have the option for stiffnesses in here. So, for example, if I wanted to mostly pin those in position, but in the Z direction, give them a stiffness, spring stiffness in a particular axis, we can do that. Likewise, if I double click on a node, or double click, in fact you can double click on just about anything in GSA, it will open up the relevant edit dialog for that thing that you've just clicked on, whether in the graphical view or in the table views. And then I can change the settings directly with these coordinate systems, or indeed the the restraint properties. And while I'm at it, actually, let me just right click on that one and say I want to set no defaults as this, which is pinned, no other changes, and I'm going to use the modify node sculpt tool and just pick that one there, pick that one, and it then sets those node defaults to pinned, and I'm going to set them back to free so any new nodes I create aren't automatically pinned. We need sections in here as well, so at the moment we've got no section properties, so I'm going to open up the section dialog and I'm going to double click on this line and it opens up the section wizard, and I am going to use, let's just use a nice channel section. Note in the latest build we did add in some additional catalogues including South African and the ASTM. So I'm just going to choose a chorus 200 channel for the moment. And we also need loads in the structure. Now loads we can apply just by picking elements and say copy that as a list and just paste those elements into the list. We can see them in there, or alternatively we can pick a number of elements. Now right click and say save that as a list. I'm going to call that landing. And if I tuck that down the bottom using the keyboard shortcuts, I can pick that list that I've just created and those are loaded as well. Or alternatively, if I was to just delete that, and in this list here I am going to use, rather than list of element numbers, I'm going to use a property reference, which if I type something nonsensical in there, you should get a dialog up which shows syntax of what the options are. And in a particular case you can do some quite complicated things, but I just want property beams, beams property number 1. So I'm going to type in PB1, and you see everything which has a property reference property beam 1 receives that loading. This can be very useful, especially when dealing with 2D elements, because you don't really want to have a list there to look after those, especially if you're doing auto meshing. All right. That's 1D elements. Now we do also have 0D elements in GSA. And 0D elements are quite curious little things. There's a couple of them. Element, we have ground springs and masses. Now a mass, for example, let's go to my properties. Now a mass is essentially, it's a weight which you can specify in a particular direction, and I'm just going to say this is 100 kilograms, and you can give it inertias in particular directions. These are mostly used for dynamic analyses, but you can use them in static analysis as well. And what this will do is it will add a mass onto the structure, which is then used in the self-weight calculations. So if I let my data defaults, change my element default to mass. Again, that's property number 1, and I can just sculpt these in and just stick a weight on there. And you can see the symbol there is a square. So if I go to my labels methods, I can change that to a different symbol, which is quite cute. Now the other type of not the element is the ground spring. Now ground spring, well, we have springs which are either 1D or 0D springs, and I'm just going to create a spring property which is global, and it's a translational spring, and I'll just give it some general properties. Now, cunning thing about ground springs though is that you can make these compression only and make sure it's vertical. Now if this is a vertical compression only ground spring, I will just go into that element there, make sure it's completely free, just give it an X and Y stiffness, and then what I'm going to do is on my data defaults I'm going to change that to a ground spring, and again just sculpt in a spring at that point, and you notice this ground spring is a slightly different symbol to the spring stiffness on the node value. And because that's compression only, it will resist downwards but be free upwards, a bit like the ground. Okay, that's look at 1D elements. Well, 2D elements. Now, 2D elements, the axes on 2D elements are slightly more complex than 1D elements because you've got more points to play with. First of all, the local z-axis, the upward direction of the elements, is defined by taking the two diagonals, then using the right-hand rule. That if you go anti-clockwise or counterclockwise around the nodes, the z will then be upwards. Once you've got that, then there's the definition of the local or global axes. Now, if they're defined by the local axes, the local x of the 2D element is then parallel to the first edge defined. And you notice this element from node 1 to node 2, parallel to the x. This one from node 1 to node 2, x is parallel. You can define elements by or the rotation of elements by a different axis. Obviously, it's a global axis which is supplied, and you notice now the x and y's are parallel to the global x and y's. The global axis doesn't work for vertical elements because they're not parallel to the global axes. So the results for vertical elements can be a bit unpredictable. Recommendation here is to create your own local axes on those wall planes, and then define the elements using that user-defined axis set. If you're just doing general analysis, it's not too crucial, but if you're doing the reinforcement design with 2D elements, it is totally essential to have good control over where the element axes are going. Otherwise, your design aspects will be nonsense. Let's have a look at 2D elements in action. Let's just get rid of that, and I'm going to create a new model. And I am just going to draw in a couple of elements. Now, with 2D elements, we do have some choices, the quads and the triangles. Now, when it comes to drawing elements in, it's always better to use the quad 4 or the triangle 3 because you don't have to worry about defining the mid-side nodes. But you can convert the elements between these two types afterwards. So if I'm going to do a quad 4 is now obviously it is a 4-sided element, and the triangle three-sided elements. Now I mentioned we can select those two, and we can modify those from the linear, which is the quad 4, the triangle 3, to the parabolic, and that automatically creates the mid-side nodes. Now these elements are more accurate in the general analysis, though these days now we have the MITC formulation. You don't need to use parabolic elements for the analysis. In fact, for analysis, generally recommends you start off with the linear elements to begin with, and then maybe go up to the parabolic if necessary. Now, having drawn in large elements, what I'm going to do now is I'm going to split these down into smaller pieces because these are too big for detail analysis, and I'm going to use the sculpt tools. First of all, split quad elements and break that down into, let's say, 4x4. And the split triangle needs to be a slightly different command. And we can use the again, split under 4 elements on the edge, and that splits the triangles into more triangles, or you can split the triangles into quads, and maybe adjust the diagonal option, which is going to be generally good apart from this dubious element in this. Put that out to 2.5, and that element there, which is getting a bit stretched, I am going to split that split that quad into triangles, and it takes the angle with the largest corner with the largest angle and goes across the diagonal. Now, I've got my general nodes here. I'm going to add in a node point in there using the sculpt tool, and this node, and my corner points. I'm going to right click, modify. I'm just going to pin those in position. So these are my support points. Now this node here doesn't actually join on with the mesh at the moment. So I've got another sculpt tool, which is drag nodes, and I'm going to take this one and just drag that node up into position, which means we've got the mesh all joined together, so when we analyze this it will work. We can also do other adjustments on this mesh off. We can use the split commands, but with a 2D mesh like a flat slab or so on, you want sort of quite large elements in the middle where not much is changing. So you've got general moment but not much detail, but around the support points the moment's changing quickly, so you need a finer mesh to catch the detail. Now if I take this element here, we can refine that mesh, and which corner it is. Okay, so 1, 2, 3, 4, so we know corner 3. You see this is splitting this quad element up into 3 new quads with a smaller mesh at that nodal point. It's all right around the corners, but for them refine the mesh around this node here, I don't want to do each element individually, so I'm going to select that node and I'm going to use the refine mesh at nodes, and this will work on quads or triangles, and you can see it then refines the mesh there, and we can repeat this command as appropriate. I mentioned about element axes. If I switch on my element axes, so either the general X axes or under my labels axes or element axes, so we get the full X, Y, Z. You see, by default everything is currently set to a local property. So if I go to my 2D element properties and just tuck that down the bottom, I'm going to change these to be defaulted around the global axis. We've only got the one axis set defined in here. Because it's going to be a flat slab, I'm going to put them in as a flat shell, so it has bending and in-plane stiffness. A plane stress is just a membrane, so it's in-plane stiffness, and a flat plate, just bending stiffness. And there's fabrics which are tension-only elements. Long-term concrete, I'm going to give it a thickness of 300 mil. Factors here, bending factor. This accounts for the bending stiffnesses, or the stiffness of the elements, is based on the gross concrete cross-section. But with effects of reinforcement or pre-stressing or whatever, we can either, let's say it's 275 effective thickness, or it might be 90% or 110% of the effective thickness. And likewise, there's the in-plane factor, which allows for voids and hollows within the concrete. Let's say it's a hollow core slab or something like that. In this particular case, I want it full mass, and this affects both the in-plane stiffness but also the self-weight as well. Can also add in additional mass, which then taken to the self-weight calculations. And you notice now all the elements were axes all aligned all over the place. They're now all parallel to the global axes, which means any reinforcement design is then going to be sensible. Okay, now with these axes, right? Now you can rotate the axes on these elements, but if you're going to do reinforcement design, I recommend you better go to a user-defined axis instead. Now this is alright for a nice simple structure like this. What I'm going to do now instead is I'm going to delete out all these elements. Actually, well, let's just copy those nodes. Select those nodes, and I'm going to copy them over a bit, and I'm going to use, well, if you could use the copy, I'm going to just draw a polyline, and I want it to copy from there to there, and with this polyline, go back to my nodes and go to the copy. I didn't know what the distance was, but the polyline knows how long it is, and it'll by default copy them by that vector. Click that, and I'm going to mesh this right hand version instead. Now I want to change over from my analysis layer to my design layer, and the background changes slightly, and you can also do a Control-Alt-D to swap between the layers. And to mesh this part, I'm going to use an auto mesh, and meshing is defined by lines, areas and regions. You notice now we've now got additional buttons: add lines, select areas, select regions. So I'm going to add a line. I'm going to add a line from there to there, and if I hold the control down, I can keep going round until I get to the last point where GSA has detected there's a closed loop, and say, do you want to add an area? Now an area gives the element properties, and we could include a void within the middle of this. But let's do that. I am going to add a void in the middle. So we've got two areas. I'll go to my area selection. I'm just going to double click on that area there. I'm going to say that is going to be a void. You see, we now get a slight, you might be able to not see that, it's just a slight little grey cross showing how to turn the void in there. So I'm going to select those two areas, and I'm going to select that node, and let me go back to area selection, and I can right click and say add a region. And so this region will pick up node 73 and the two areas. I don't need to select those additional lines because they're defining the areas already, so they're by default selected. If I had additional lines in here for maybe wall lines and so on, I would need to include those in the region here. And now if I do an auto mesh, interesting, I've got the machine's giving me a warning about angles in there, but you see it has meshed, but it's saying the angle is getting a bit small on well, got small angles over there, but we've also got some small angles in this side. Now I'm going to change that region property. I'm going to double click on that region definition. I'm going to change that to a linear, and then remesh, and maybe slightly better but not quite. And I'm going to edit my lines now, and rather than number of segments, I'm just going to default that to step size, and just take that default from the top, delete out the contents. These now will be a step size of 1 meter. It's just that the table needs refreshing. If I remesh that, no errors. Excellent. So we've got quite a reasonable mesh on here at the moment. Now notice as well, this node up here, this is tied topologically into the mesh. Now I'm going to edit that node. In the moment, if I right click directly on that node, at the moment it has no mesh attributes. But if I tie that node to the mesh instead, GSA will not try to include that node directly as a topological tie into the mesh. It will create a constraint at that point. Let me just switch off the color contour so we can see a bit better. You see, this node is now constrained to be on the surface of that element. If I switch the axes off and switch my tied interfaces on, you see this node is tied to this element. So when they move, they will move together, so such as this node remains fixed on that surface. Now we can't, this will create a double constraint on this node, so I'm going to edit that node, because we can't pin that node and have it in the constraint. So I'm just going to free that node up, On the other hand, this could be a good place for, where that node select is, just create, right click and create a load on that point. So you can have point loads on your slabs without having to actually tie the node in, and because that can create some quite complex meshes if you're not careful.